Hello children, so we are here with the video on financial sequences, okay, which includes financial simple interest, compound interest. They sound very difficult but they are very easy. Actually they are following simple interest is arithmetic sequence and geometric sequence is compound interest is geometric sequence. So if you remember these two things, it becomes very easy. Remember, see what I said, simple interest is arithmetic sequence because fixed amount of interest gets added every year or at the end of every period. So typically simple interest is given on a yearly basis, so it is yearly basis. Every year a fixed amount of interest gets added to your principal amount. So it is an arithmetic sequence. Geometric sequence is interest on interest. So whatever interest is accumulated on geometric on an amount, the next year the amount is calculated on that particular thing, which is increased amount. So it is always compounding, like interest on interest, I would say in simple words. And in mathematics we can think of it as a geometric sequence. Okay, so we have some questions. So these are type 7 questions in our website examprep.world. I always suggest you should do this because I am giving this instruction video only with some set of questions which actually give you fair idea of how to do those questions. Okay, but you will have to go and do the complete exercise. And if you get stuck at any point, you have been given the solutions. So you can always look at the solutions and see for yourself if your solutions is not only the answers, exactly the whole pattern or whole question has been done in a detailed way. You can look at that at steps, and you will, once you do that on your own, you will get the hands-on experience on it. Okay, so without wasting time, let's begin these type of questions. Okay. If you are finding it difficult to read here, you can open our website examprep.world. In that, go to sequences, go to type 7 questions. This is the first question. Okay, here it is about simple interest. See, $1,000 is invested in a simple interest. Though we will note our words simple interest, and rate of interest is 7%. Okay, so we should catch the keywords whenever there is a word problem. They have told it is simple interest and the rate is 7% per year. After 1 year, the value is obviously $1,000. So what happened? Okay, $1,000 and 7%. So that means $1,000 is invested. This is your principal amount or the present value of money. Okay, so 7% of $1,000 is $70. So you will get $1,070 at the year end. But what about the second year? The interest amount every year is $70. So in second year also you will get only $70. You won't get 7% of $1,070. Okay, so that is what it is. So he's asking, find the investment at the end of 3 years, 4 years, 5 years. Okay, so first, because it's a arithmetic sequence, the first, at the end of first year, how much you are going to get? 1,000 plus 7% of 1,000, which is 70. You are going to get $1070. Next year, you will get how much? U2 is 1070 plus another interest 0, which is 1140. Okay, so at the end of year 1, 1070. At the end of year 2, so you just add, U3 will be 101140 plus another 70. So this becomes 0, 1, 2, $1,210, right? So this is how the amount was increasing every year with a fixed amount of 70. So after 3 years, we already have calculated what is our U1 here. U1 is 1070. End of, so U1 is 1070 and D is 70. Correct? Don't take U1 as 1000 because we are doing U1 at the end of first year. At the end of first year, already it was 1070 and interest is how much? 70. So this is U1 is 1070 and D is 70. With this, you can find amount at the end of any year, right? So at 5th year, what is the 5th? What is general formula? UN is equal to U1 plus N minus 1 times D. This is the general formula for arithmetic sequence. It is following arithmetic sequence. U1 and D is there. Okay. So what is U5? U5 will be 1070 plus 5 minus 1 times 70, which is 1070 plus 4 times 70, 1070 plus 280, add 280 here, 053. So it will be $1,350. Okay. So we get, after 5 years we calculated 1350. 3 years we already calculated here 1210. 4 years add another 70, 1280. Okay. So this is very simple. The part 1 is done. So don't get tensed by looking at the size of the question. The wordings are obviously large because they are trying to explain a case, and they have to use a lot of words and sentences. But real mathematics will be very, very small. So never worry about big questions. Okay. Now part 1 is done. Do the amounts form an arithmetic sequence? Yes, we already identified it is arithmetic sequence. So it is arithmetic sequence. Why? Because there is a common difference of 70. Okay. So it is not geometric sequence. It is definitely arithmetic sequence. Explain your answer. How will you explain? Because the amount at every year, after every year, is following a general trend with a common difference of 70. So the moment we have common difference 70, we say it is arithmetic sequence. Okay. Now write an explicit formula for the sequence. So explicit formula I actually wrote here. This is the one. So UN is equals to 1070 plus n minus 1 times 70. Here in explicit only n is the variable, rest all data you have to go. When in recursive you will have to put even this one as n. Okay. So let's write what is this. It is 1070 plus 70n minus 70. So it is 1000 plus 70n. This is your answer for C, explicit formula. So whenever you need it, you can test actually, you can put 5 here, 5, so 350 plus 1000, which is U5, 350. So explicit formula should immediately give you the result. Okay. Now what about recursive formula? Which is this term? Any term, previous term, then next term. So we will write recursive formula here. Let me zoom out. Now at this stage you won't be able to read on the board the questions, but definitely you can see my working. Okay. So if you want to see the wording of the question, you open another window in your computers where you can open examprep.world and go to the sequences, go to type 7 questions. This is the first question. Okay. Now D. We have come to part D. T is UN equals to U n minus 1 plus what? 70. Any term plus 70 will give you this next term. This is recursive formula. Okay. Very, very simple. So any term, previous term plus common difference. Okay. So with this, we have completed this question. I hope you have understood. Okay. If you have not understood, I went very slow. You can go back, rewind, pause at each step, do with yourself, you will understand. Okay. So let me go to the next question. Now it is compound interest. Okay. Compound interest, what did I tell you? They follow GP. Okay. It is geometric sequence, geometric progression. I say GP is geometric progression, GS is geometric sequence. Both are same things. Okay. So let us see this question. 6,000 is invested. So present value of money is how much? $6,000. So we will mark that things. $6,000. Rate of interest is how much? 7%. Compounded over a lengthy period. The interest paid is at the end of each year. That means it is also compounding only on yearly basis. Okay. Now when these kind of questions come in sequences, don't go with your compound interest formula. We have a definitely compound interest formula. We will learn those things also. But here they have given certain general rule. So we will follow these rules instead of the basic compound interest formula. Okay. Now look at this. After 1 year, obviously the rate of interest will be 6,000 into 1.07. Why 1.07? 6,000 plus 7% of 6,000. Okay, I'll show you what it is. 1,000 plus interest is 7% of 1,000, which is, I can write this 7 by 100, can I write 0.07? 0.07. 0.07. Instead of 7 by 100, I wrote this. Now, can I take 1,000 common? 1,000 into 1 plus 0.07. Okay. What is this? 1 plus 0.07? 1,000 into 1.07. And that is precisely written here. After 1 year, this is the amount you get. After 2 years, this amount plus further 1.07, because it is increasing again by 7%. So it is, after 2 years, it will become 2. You are seeing this square here. So after 3rd year, obviously, it will become 3. Now you have to explain why. Okay. So I will write this one. U1 is how much? 1,000 times 1.07. U2 is 1,000 times 1.07 whole square. Since it is a geometric sequence, U2 divided by U1 is how much? 1.07. Therefore, U3 will be, once more we have to multiply R. So U3 is, we divide, R is 1.07. And this you multiply to the second term to get the third term. Therefore, it is 1,000 times 1.07 whole cube. Because this divided by this also should be 1.07. So what explanation you are going to give? Explain why the amount in 3 years is given by this. You say because the common ratio is 1.07. So the third, at the end of year 3, it will be amount 1.07 multiplied by this particular thing. It becomes cube. At the end of 4th year, it will be 4, 5 and like that. Okay. So write down the same for the amount after 4 years, 5 years, 6 years. Okay. So after 4 years, how much it will be? 1,000 into 1.07 whole to power 4. This will be 1,000 into 1.07 whole to power 5, because once we have identified a general rule, it becomes very easy. Okay. And after 6 years, it is 1,000 into 1.07 whole to power 6. Correct? See, don't again confuse, ki sir, this is n minus 1, so it should be 3. No, because we have calculated our sequence at the end of the year, not at the beginning of year. At the end of year, it was already 1,000 into 1.07. Okay, that's why 1.07 is there. Although the R is the same, it is 1.07. Any term divided by the previous term will give you 1.07. Okay. Do the amounts at end of each year form a arithmetic sequence? No. They form a geometric sequence. Explain. Because the common ratio is 1.07. Okay. How do you explain that? You can always tell, after writing the sequence, you can tell that U2 divided by U1, which is the common ratio, is also equal to U4 divided by U3 or U3 divided by U2. When R is same, that means it is a GP. This implies that the sequence is geometric sequence. Write down the explicit formula for the sequence. Very easy. So, D part. UN is 1070 okay, because it is 1000 1.07 whole to power n. Explicit formula done. Okay. Now recursive formula. E UN is equal to U n minus 1, previous term times 1.07. Previous term, any term is a previous term multiplied by 1.07. That is a recursive formula. Okay. So both formulas are written. With this, we come to end of this question also. I have collected one more question of compound interest. Let's see that one also. Okay. Pause, do yourself. Okay. Yeah. Now here they are talking about a photocopier which originally cost $12,000 and depreciates. What is depreciation, children? Depreciation is when you buy a new thing, after a year or so, can you sell at the same price? No, it loses its price because it becomes old, and that is called depreciation. And depreciation is fixed amount, at a percent it depreciates every year. Suppose you buy something for $100 and it depreciates at a rate of 10%. At the end of year, what is its amount? At what you can sell? 100 minus 10% of 100, which is $90. And in second year, it will depreciate once again by 10%. 10% of $90 is $9. So you can sell for $81. So slowly the price will keep decreasing year by year, and that is called depreciation. So when you buy a photocopier, very new photocopier for $12,000, very costly, costlier than a car. Yeah. So, and it depreciates 20%. Depreciation is also very high, so it will become old very fast. In 5 years almost it will become free. Okay. The end of 1 year, its value is 80%. This is 20%, right? So 20% if you remove, balance is how much? 80% is left. That's why they have written 0.8. 80% is 0.8. So $12,000 into 0.8 is the value after 1 year. Now find its value at the end of 2 years. So it is very simple. 12,000 times 0.8 whole square. 2 times 80% and 80%, right? 3 years. 12,000. Now you don't even have to think of finances. It is simple mathematics. 0.8 whole cube. Now it's a GP. And U1 was, this is U2, this is U3, this is U1. Now you have 3 terms of the sequence with common ratio, which is 0.8. Okay. Do the resulting annual values form an arithmetic sequence? No, it does not form an arithmetic sequence. What does it form? Yes, it definitely forms a geometric sequence because the common ratio is same. How do you explain that? R equals to 0.8. You can check by U3 by its U2 is 0.8 and U2 by U1 is also 0.8. So it is definitely a geometric sequence because we have a fixed common ratio. Okay. Now C, explicit formula. So UN equals to $1,000, it is $12,000, right? $12,000 into 0.8 whole to power n. As simple as that. And recursive, UN is, previous term will be obviously UN minus 1, and what is the common ratio? 0.8. Your recursive formula, explicit and recursive formula done. So if this kind of question comes, you will straight away, you can very easily score your 4 marks in exam. This will be not more than 4 marks. It's a simple question, looks big, but they are really very small. So I hope you have understood financial questions in sequences. Okay. So with this, we come to end of this, and okay. So with this, we come to end of these type of questions, and I suggest keep practicing. Okay. Thank you.